The example number 4 for the relative velocity equation is about a mechanism that using the plunger here to push the gear. As the gear is going to be rotating, it's going to start to push the road. Uh, it's going to be push the gear rack to the right. So this one is going down. This will rotate to that direction. Okay, and cause the point A to have the velocity in this point to push the rack at the same velocity. So the analysis of that shape is going to be consist of, we need to find the R from the point C to the point A. So if I get to connect a line from here to here, I can tell that that distance is equal to 0.3. And from this point to here, this distance is going to be equal to 0.4. Both are given here. Now I'm going to connect the link CA, and the CA is going to have two components, which is going to be 0.3 for the I and 0.4 for the J. And that's how we're going to start to do our solution. Now we're knowing that this velocity is only going to have a J component in the negative direction, and the velocity A is going to have an I direction in the positive direction. So we have everything ready. Let's start to do the work. So that's the same diagram I just described to you. And we are going to make a relative velocity equation between the point C and the point A. So the velocity at A is equal to the velocity at C plus the omega of the AC multiplied by the radius A slash C. We start from there. Let's try to find every component we have. So for the RAC, okay, we said once again equal to 0.3 I minus 0.4 J. So this one done. The omega ACK is going to be multiplied by both two. This one is equal to negative 6 J. And this one is only have the VA I because only going to have a horizontal movement. So now that's what we have. The VA is VAI. The VC is minus 6J. The RAC is 0.3I minus 0.4J. Now y point minus 0.4. First, the 0.3 because we're moving from the point C to the point A from the right, left to the right, so this will make it positive. While when I get to move from the point C to the point A, I get to have to go downward, and this will make it negative. Now multiplying that by the omega ACK, so the K times the I is going to be the J, so it's going to have 0.3 omega ACJ. And when I'm going to multiply the K by the J, this will give me negative I. Negative I minus, multiplied by minus 0.4, this will make it positive 0.4 omega ACI. Okay, now just put everything in the relative velocity equation. Now we can see that we have this one and that one have the I, and this one and that one have the J. So we can simply start to do the solution. Now I cannot start with the I because both are unknown, but I can say that the minus 0 minus is equal to minus 6J plus 0.3 omega ACJ, and rearrange the equation, and I will find the value for the omega AC. Then I will say that the VAI is equal to 0.4 omega ACI, and then I substitute the value of the omega AC, and I will find the velocity at the point A. So let's add the two parts by solving each. The omega AC is equal to 20 radian per second, and the VA is going to be equal to 8 meter per second, and thus we found the answer for both points.